Alrighty, hello everyone, and thanks for joining me on another video. Now, today we are talking about just bringing together all of the ideas we've done so far on algebraic expansion and expanding binomials into a nice, concise, and efficient process. And this is what we're going to call the FOIL method. So, I'm hoping you've watched the previous videos on binomial expansion and using this area approach that I talked about. This will give you, I hope, the intuition into how these type of expansions work. But now, unfortunately, in the real world and when we go to tests in school and stuff like that, unfortunately, we have time constraints. So it's not super efficient to be drawing your little rectangles every single time and taking the area approach. We need in these situations, once we've understood the intuition, we just need a quick and efficient approach. And the FOIL method is what I learned in school. We didn't even talk about the area approach. We just went straight into this FOIL method and expanding quickly, which is cool. But if you haven't watched those videos, I would highly encourage you to, just to give you a bit of the intuition into how we work with these. Now, with the FOIL method, this is basically an acronym. So the FOIL method looks at a polynomial, sorry, not a polynomial, a binomial product of, let's say, okay, x plus 7 multiplied by x plus 3. The FOIL method essentially gives us an order in which to compute this binomial product quickly. So the FOIL method essentially, I'll write it here. So the FOIL method basically tells us to, when we multiply binomials, we have to multiply the first elements together. So our F stands for first. Our O stands for our outside ones. So here our X and our 3 are our outside ones. Outside. Our I stands for our inside products. Inside. And L stands for the last. So these two are the last ones in terms of the binomial. Now, if you've got a bit of the intuition from the last videos, you may notice that the order doesn't necessarily matter, but the idea of FOIL, it's a word that we know, it's a good acronym to remember exactly what we do here. Now, if we were to expand this using the FOIL method, we'd say, well, we would get, multiplying the first elements, we'd get x squared, multiplying the outside, we'd get 3x, multiplying the inside, we'd get 10x, and multiplying the last, we'd get 21. Now, we notice here we have two like terms. Oh, I have gotten ahead of myself. That's meant to be 7x. And when we add these elements together, because they have like terms, we can get x squared plus 10x plus 21. Cool. That is essentially the FOIL method. But the way I like to think of it as well, instead of thinking of this as like an order or whatever, I like to think of this as, well, each of my elements in my binomial, by elements I mean each one of these, each of them have to interact with every other one at least one time, right? So looking at the area approach, the order that we did these in didn't really matter because it all summed up to the same area. Whether we multiplied this one and this one first or anything, we still got to the same thing. But let's think of this as all of the elements interacting with each other. Now, a good analogy I like to use is, say I'm going with a friend of mine to visit two other friends, to meet up with two other friends who are here. Now, how I like to think about this is that if I'm going with a friend of mine and we're meeting up with two other friends here, let's think about how that greeting is going to go, right? Because I'm going to go and I'm going to come and say hi to this person, and I'm going to say hi to this person as well. And likewise, my friend is going to say hi to this person and this person. If I were to go up to this friend of mine, but then totally ignore my other one here, I'd look pretty rude, won't I? Like everyone's gonna think, well, what's up with this guy? He's interacted with one person, but not the other. So when we meet people, we interact with everyone. So each person here is going to interact with each person here in the same way that each element here of my first binomial is going to interact with each one on this side. And the FOIL method just mathematically represents that. It gives us a nice acronym to remember the process. We have our first ones kind of interacting first, then we have our outside ones, then we have our inside ones, and our last ones. And that is a quick and efficient way to multiply binomials, to work with binomial expansion and binomial products.